Hello everyone and welcome back to the next session on pointers. In this particular video, we are going to have a look at how pointers is associated with arrays and functions. So we have arrays and pointers. Now, arrays and pointers are closely related in C programming language. In fact, an array, for example, if it is declared as int a of 5, it can be accessed using its pointer representation. That is because the name of an array a, right? Here a is the name of an array. It is a constant pointer to the first element of an array. So actually speaking, arrays and pointers are synonymous in terms of how they use to access the memory. But the important difference between them is that a pointer variable can take different addresses as value, whereas in case of array, it is fixed. Okay, so that's the fundamental difference, right? I reiterate, pointer variable can take different addresses as values. On the other hand, in case of arrays, it is already fixed. Now, that's what I said, right? So you have int a of 5, right? And you have 5 subscripts of an array, a of 0 to a of 4. And let us say the starting address is 101. And I'm assuming here integer takes 2 bytes. So I have array starting from 101 and goes up to 110, right? Now, in programming language C, right, whenever we have discussed arrays, we have made a statement that whenever you refer an array, you always get the base address, right? So name of an array always points to the first element of an array. Do you agree? Name of an array will always point to the first element, which is that element here, a of 0, right? And what is address of a of 0? 101. And hence, address of the first element of an array is nothing but ampersand of a of 0. You agree with me? Right? And also, a represents the address of the pointer where it is pointing. And hence the conclusion drawn is ampersand of a of 0 is equivalent to a. Okay, ampersand of a of 0 is equivalent to a. That's what we say. Whenever we refer an array, we always get the base address. Okay, now let us try to understand this or justify this with the help of simple C program. So I have my compiler ready for you. Let me take an array without any initialization. So that's the code written for you. What I'm trying to do is I'm trying to print the address of each and every element of an array with the help of this for loop and printf in line number 7. And in line number 8, I am trying to print the address of the starting element of an array, right? But of course, here I'm just trying to print the address by just referring the array name a, and whereas here I'm trying to print it by referring with respect to subscript, and when the value of I is 0, it will first print ampersand a of 0. That is again nothing but the address of the starting element. So let me run the program for you and let us see what is the output. Yeah, here is the output. Okay, so I have a of 0 as 198.180.544. For discussion, let us consider only the last four digits. And here it is taking integer as 4 bytes. So I have 544, then plus 4, that is 548, 52, 56. So all the way from 0 to 5, I have these addresses. Okay, and then if you look at the ampersand a of 0, it is giving me 0544, which again I am trying to print with the help of name of an array, and hence you see this particular output and this particular output both are same, right, which is nothing but the address where the starting element of an array is stored, right. So when I look at this, I will say this is the address where the starting element of an array is stored, and when I look at this, I can make a statement that whenever you refer an array, you always get the base address, right. So that is how you can always access the elements of an array, right. So I can also run this for 4 because I have this subscript as sorry, the dimension as 5, and let me see, there will be definitely small changes in the output because the addresses are runtime. So I have 5824, 5828 and so on, right, and then this 5824 I have here also, right. So that's fine, right. So that is how it works actually in C. Okay, let us look at it. Arrays of pointers, right? Now, in computer programming, an array of pointers is actually an indexed set of variables. Okay, I repeat, in computer programming, an array of pointers is an indexed set of variables where variables are pointers. That means what? It is referencing a location in the memory. Now you know that pointers are an important tool in computer science for creating, using, and destroying all types of data structures. An array of pointers is useful for the same reason that all arrays are useful. That means it allows you to numerically index a large set of variables. Have a look at this particular code, right, and then we will code it directly in our in our compiler. So what I do is I'll not waste time in typing the program. I can as well take it from here. Okay, and then I will paste it for you. This what I have, right. So just have a look at it. So this is my right. So I have array of pointers of 4 dimension. I have a couple of local variables I, j, k, l, and m. And what I'm trying to do is I'm trying to say ARR of 0 is equal to ampersand of I, ARR of 1 is ampersand of j. Like that I have for k and l as well. And then with the help of for loop, I'm trying to print the value of that particular array, right, with the help of pointer variables. So let me see. I'll compile and run for you. This is expected identifier. So somewhere there is a problem. Yeah, here it is. That's fine. I think I got rid of it. Okay, so that's what I get. I get the answer as 31, 5, 19, and 71, right? It is the same output which I have assigned in line number 5, right? So let us see how basically it works is these are the local variables I, j, k, l which are stored in some addresses. I think I have those addresses in my PPT. Okay, so this is what it is. Now, have a look at this. and the memory map is drawn here. Right now, these are my four variables I, J, K, and L. Right, and the values of I, J, K, L are 31, 5, 19, and 71, which we have already seen in the previous code. Now assume that these variables are stored in addresses which are given here. I is at 4008, J is at 5116, K is at 6010, and L is at 7118. Okay, so this is the memory map for your code all the way from this particular place, uh, right, from this particular int star arr till here, right, till ijkl. Now the next statement is arr of 0 is equal to ampersand of I. So we need to have a memory map for an array also. So let us see the memory map for an array. Now this is the memory map for my array. ARR of 0, ARR of 1, ARR of 2, and ARR of 3. Now the base address is 7602, and assuming that it is taking 2 bytes, since it's an array, the array elements will be stored in one continuous memory location. So 7602, 7604, 06, and 08. Okay. Now when you go back to the previous code, you have this first line ARR of 0 is equal to ampersand of I. That means what? Address of I is stored as value at ARR of 0. Or I can say like this also, ARR of 0 is nothing but address where variable I is available. Right? So what is the address of I? 4008. Right? Address of I is 4008, and hence you look at here, ARR of 0 is also 4008. Okay. Similarly, we have said that in the previous slide, ARR of 1 is equal to ampersand of J. Right? What is ampersand of J? That is address of J, 5116. And hence ARR of 1 will be 5116. Similarly, ARR of 2 and ARR of 3. Okay. And then what happens? You have your for loop which says that for m is equal to 0, correct? For m is equal to 0, m less than or equal to 3, m plus plus, and you print it. So initially value of m is 0. So star ARR of m, that means star ARR of 0. Right? Now what is ARR of 0? ARR of 0 is 4008, right? And star ARR of 0 is nothing but star 4008, correct? What does it mean? We have already seen star 4008 means go to address 4008 and pick up the value there. What is it? 31, right? So the first for loop, the first value of the for loop when m is 0 will give you the answer as 31, right? And then m becomes 1. 1 less than or equal to 3, condition is true, control will go inside, and you are trying to print star ARR of m, in which case now m is 1. So star ARR of 1 is nothing but star 5116, correct? Now what is there at 5116? 5, right? So star 5116 is nothing but 5, and hence the next output will be 5. That is the prime reason you get the output as 31, 5, 19, 71. So let us continue with pointers, how it is related to function. What we call it as passing pointer to a function, right? Now, just like any other argument, pointers can also be passed to a function as an argument. Okay, I repeat, just like any other argument, pointers can also be passed to a function as an argument. Right now, to illustrate this, I will demonstrate this particular concept of pointers to a function with the help of a C code. So let me go back here. What I'll do is I will try to develop a code using user-defined function, which will enable us to swap the contents of two variables, right? So I'll write the main program first. So I say int num1 comma. So just try to see how the programs are developed. So this is my user defined function which I am going to call as call by reference. So I think I'm done with my main function. Now I have to write the definition part. Let me write the definition here itself. So I can just say void swap num because I don't want it to return anything. So I'll have as a pointer variable because I'm using call by reference type. I'll use a temporary number and then I say temp num equal to star n1. I think this should be fine. I hope this code should work. Looks to be fine for me. Yeah, so it's asking enter two numbers. I just enter 12 and 56. Wow, that's fine, right? So it says before swapping, it is 12 and 56, and after swapping, it is 56 and 12, right? So this is what I'm doing in line number 16. I am implementing the concept of call by reference, and then like any other argument, the pointers can also be passed to the functions as an argument, right? So you can always justify this with any example that is related to call by reference. Okay, so this is how I can always pass an argument to the function, but it is actually a pointer argument that I am passing to the function. So just have a look at the code once again. So this is my definition part where these three lines are responsible to swap, and this is my main program. Line number 16 is what I'm implementing call by reference. So let us proceed to the last aspect of this particular session, that is find the validity of the code. Of course, I'm not going to explain you. I'll give you some time to think and try to scribble it on a piece of paper and then find out what is the answer for this. So since this is a video, what I suggest is you pause the video here, correct, and then you take a piece of paper, scribble it, do the hand run, and then try to get the answer, and then you continue with the video to find out whether the answer that you got is correct or not, right? But the answer for this is it's a syntax error because we have already seen that you cannot perform multiplication and division on a pointer variables, and hence j is equal to j star 2 or k is equal to k by 2 is not valid in this particular piece of code. So the output is 0, 20, 0, 40, and 5. It is self-explanatory. Just try to draw the memory map and try to get the answer.